is a problem. Why, you know? Now, if you really want to know what is the problem and how mitochondria overcome this, you should understand something called dihydroxyacetone phosphate, glycerol 3-phosphate shuttle. There is something called dihydroxyacetone phosphate, glycerol 3-phosphate shuttle. This is the, yes, okay. Now listen, you should understand one thing, how this is occurring. Now listen, now listen. In the biochemistry class, we have already discussed how to draw every structure of any molecule, right? How you can draw every structure possible on this earth using your simple organic chemistry base, right? Now listen. Now listen. Suppose here is a happy-go-lucky NADH. Is it coming in the camera? Yeah. Suppose here is a happy-go-lucky NADH which wants to participate in electron transport system. But the sad part is it cannot cross the second mitochondrial membrane or inner mitochondrial membrane. Now listen with all your attention possible. For this NADH, if this NADH wants to get involved in ETS or want to participate in ETS, the only thing is this, it will have to donate its electrons to a protein which is already sitting here. It will have to donate its electrons to a protein which is already sitting here, right? It will have to donate its electrons to a protein which is already sitting here. That means they will give 2 electrons to this protein and they will become instead NAD plus H plus, right? Okay. Now listen, don't guess anything. Now listen, no, you are telling wrong things. Listen, you are telling, what you are telling is these 2 electrons will now be available to FMN, right? No, absolutely no. Now listen, before guessing you should understand what is going on. Now listen. No, what you are guessing, these 2 electrons will be taken up by this NADH. That means it will become NADH2. Oh my goodness, I don't know how this is happening. Maybe inside your body only it is it's a special case, but actually now all of our bodies it is not a special case. Now listen. Now listen. These 2 electrons will now be transferred to something called dihydroxyacetone phosphate. You know how to draw dihydroxyacetone phosphate, Mr. Special Case? You don't know, okay. You know how to draw acetone? Very good, I am proud of you. This is acetone. This is dihydroxyacetone, one of the keto trios. This is dihydroxyacetone phosphate. Now listen. This electron will now be transferred. This electron will now be transferred to this dihydroxyacetone. Now listen. This electron will now be transferred to dihydroxyacetone phosphate. Now listen. Suppose this is your dihydroxyacetone phosphate, okay? Dihydroxyacetone phosphate. Now listen. Suppose these 2 electrons are now transferred to dihydroxyacetone phosphate. Now what will happen is what will happen is, now listen, this is dihydroxyacetone phosphate, right? Now listen, this dihydroxyacetone phosphate will be reduced to this. What is this? Glycerol 3-phosphate. So you are not understanding how this has been converted to this. Now listen. Before you again start guessing, right? Listen. This was dihydroxyacetone phosphate for you. Dihydroxyacetone phosphate for you. Now listen. What this electron is doing is, this electron has been donated to this particular substrate, and this particular substrate has now electrons, and it is taking H plus with it. H plus. It is taking extra H plus. That means H plus plus electron H plus plus electron H. That means these two. Now listen. What these two H's are doing is, they are being added like this. These are your hidden electrons. Okay. What is this? Glycerol 3-phosphate. And what is this? That means what we are simply doing is, we are reducing dihydroxyacetone phosphate, nothing else. We are simply reducing dihydroxyacetone phosphate. Now, we have successfully reduced dihydroxyacetone phosphate to, glycerol, not glyceraldehyde 3-phosphate, which is a intermediate of glycolytic pathway. Now listen, we have successfully converted dihydroxyacetone phosphate to glycerol 3-phosphate. Sorry. Now listen, what will happen is, this glycerol 3-phosphate will now donate its electron via this protein to FADH2. What? From where this idiot comes, right? Now listen. If you want to know from where this idiot comes, okay, you should know, you should understand that this enzyme's name, this idiotic enzyme's name is glycerol 3-phosphate dehydrogenase. Glycerol 3-phosphate dehydrogenase. And dehydrogenase actually takes up hydrogen, and this hydrogen will be taken up by FADH2. This hydrogen will be taken up by FADH2. We already know that whenever dehydrogenase type of reactions, whenever dehydrogenase type of enzymes are activated, then FADH2 or NADH should be there to take up the hydrogen. So they are doing it, right? Okay. Now listen. Now this FADH2 now enters TCA cycle. That's the very basic thing you need to understand. Now this FADH2 enters TCA cycle, and it will give its electron. Actually, FADH2 gives its electrons to complex 2, right? Now listen. Now listen with all your attention. You should understand one thing, that is how FADH2 is coming into this place, right? Because of dehydrogenase, obviously it's true, but actually there is a simple explanation to this. Listen, in the middle of this there is ubiquinone. Actually glycerol 3-phosphate gives electrons to ubiquinone, and it is converted to ubiquinol, and ubiquinol now gives its electrons to FADH2, and FADH2 starts ETS from complex 2, right? Now listen, I have already told you that when one NADH is broken down via ETS, it gives 3 ATP, and when one FADH2 is broken down via ETS, it gives 2 ATP. That means, listen with all your attention, the cytosolic NADH which wanted to enter into ETS, will it give 2 ATP or 3 ATP? It will give 2 ATP. That's the very basic difference between cytosolic NADH and matrix NADH. That is the NADH coming from TCA cycle. The NADH coming from TCA cycle, they will always give 3 ATP, but the NADH which is coming from glycolytic pathway, they will always give 2 ATP, because they are actually converted into FADH2, and FADH2 starts from complex 2. Okay, so that's the very basic difference between cytosolic NADH and mitochondrial NADH. Now listen.